Here's a quick overview of growth hormone. Growth hormone is a peptide hormone of 191 amino acids, and it comes out of the anterior pituitary, secreted by the somatotrophs, or acidophiles as they're stained. The stimulus for release is a growth hormone releasing hormone, and the stimulus for that is decreased glucose and free fatty acids, so it's stimulated by fasting. Inhibitors of a release, a somatostatin, increase glucose and free fatty acids, so the fed state inhibits the release of growth hormone. And it's transported in solution, 50%, and bound to a growth hormone binding protein, 50%. And it has a half-time in the blood of about 20 to 50 minutes. It binds to extracellular receptors, and it controls metabolism by raising blood glucose, raising free fatty acid concentration in the blood, and it will stimulate the release of IGF-1 from the bone and liver, which promotes growth. This slide shows you its regulation, how it's released, and the feedback mechanisms. Obviously, it comes from the anterior pituitary, and so it's part of the hypothalamus pituitary organ axis. At the top, we can see some stimuli that release hormone, like stress or sleep, release of serotonin, release of dopamine, and then that will release growth hormone releasing hormone onto the pituitary to release growth hormone. And then that will have its effect on the liver and other tissues. But here mainly we're talking about the liver. Also notice that amino acids will stimulate growth hormone released directly from the pituitary. And then we can see both long and short loop feedbacks, as growth hormone will inhibit GHRH from the hypothalamus, and somatomedin or IGF will inhibit GHRH from the hypothalamus also. Somatomedin will also inhibit the release of growth hormone from the pituitary, so there are many feedback mechanisms. Notice then that glucose and free fatty acids will inhibit the release of growth hormone releasing hormone. So this is an overview of what stimulates the release of growth hormone, GHRH, or otherwise known as somatocrinin, sleep, stress, hypoglycemia, amino acids in the blood, low free fatty acid levels, alpha-adrenergic agonists and beta-adrenergic antagonists will stimulate the release of growth hormone, as well as estrogens. And then somatostatin and corticosteroids in high doses will inhibit the release of growth hormone. Somatomedins will cause feedback inhibition, hypoglycemia, high free fatty acids, the well-fed state, and obesity. Growth hormone is generally low. And then alpha-adrenergic antagonists and beta-adrenergic agonists will inhibit growth hormone's release. This shows you what it does to the metabolism. It will increase the lipolysis of the adipose tissue. In the muscle, it will increase amino acid transport, so the uptake of amino acids, and it will increase protein synthesis. And then it increases glucose output, increases fatty acid oxidation, and increases ketogenesis. So its overall effect then is to move the metabolism away from protein sources and to utilize glucose and fats more. And it has a protective effect on the muscle. It acts on protein muscles in the same way that insulin does. It promotes proteogenesis and amino acid uptake. And then its growth effects are through the release of IGF-1. It doesn't actually do it itself directly. IGF-1 stimulates the growth, but then growth hormone stimulates IGF-1 release. And that will have effects on the bone and on connective tissue and on the viscera, where it stimulates growth and cellular proliferation. And so the one thing to remember is that growth hormone preserves the muscle when it's released, which is obviously important in fasting, where growth hormone is elevated so that you use fat and glucose, your sugar stores, more than the amino acids.